Okay, so last time we discussed about the CDF nodes. We talked about we defined what CDF is. We also have examples here. And now we are going to discuss about the characteristics of a random variable according to their classification. So random variables are generally classified according to their values that they assume. For example, if a random variable takes a finite number of values, then that random variable is called a discrete random variable. Uh, when a random variable take any uh, take any values on a continuous scale, then that random variable is called a continuous random variable. So here we will first define here, density functions. So random variables are generally classified according to the values they assume. Wala akong giingon bago lang. And then types, we have the discrete random variables. We also have continuous random variables, absolutely continuous, singular continuous, and the mixed random variables. Uh, our first, we will discuss first the discrete random variable. So we have here the definition. So random variable x will be defined to be a discrete one if x is countable or final. If a random variable x is discrete, then its corresponding CDF, this function, will be defined to be a discrete one also. So we also have here a definition of PMF, or probability mass function. So if x is a discrete random variable, then the function given by this one, so don't be confused, no? Some books will use this definition or this uh, saan siya tawagan ni? Notation. Some books will also use this notation, or some books will also use this notation. So don't be confused. So if a discrete random variable x, no, the function given by this, for each, this must be small x, sorry, typo, small x. For each small x within the range of x is called the PMF, or the probability mass function of our x. So if discrete, no, PMF lang siya. Discrete probability mass function, PMF. So we also have here a definition of discrete random variable again. So let x be a discrete random variable. So the function f x dot can be obtained from fx, from this. So you can obtain the CDF. This one is CDF. You can obtain the CDF of the discrete one from the PMF, and vice versa. So later we have example of that one. So if, say for example, we have given CDF, we can find the PMF. And if, say for example, we have PMF here, we can also write or derive the CDF from our PMF. Okay, so first theorem, a function can serve as the PMF of a discrete random variable x if and only if its value satisfies the following condition. So you can only say that the random variable x is the PMF of the discrete random variable x if the following axioms hold or conditions hold. First, condition, it must be a non-negative value, no? So each of the PMF must be a non-negative or greater than or equal to 0 for each value within its domain. And second one, the sum of all the PMF must be equal to 1, where the summation extends all over the values within its domain. So we have an example here. For example, no, uh, oops, uh, given a function. So example, let's check whether the given function f x of x. So the given function is x plus 2 all over 25, where x ranges from 1 to 5, is or can serve as a PMF of a discrete random variable. Serve as a PMF of a discrete random variable. So first no dapat kaning nga condition will hold. So let's substitute each value. So our x ranges from 1 to 5. Then we substitute our x here to the given function. Okay. So substitute. So for f, if x equals 1, then this is 1 plus 2 over 25. This is just equal to 3 over 25. If x is 2, then this is 2 plus 2 or oops, over 25. Okay? This is 4 out of 25. F equals 3. Then this is a 5 out of all over 25. F equals 4. This is 6. And 7. No, not 7. 5. F equals 5. Then this is 7 over 25. So this since these values are all non-negative, then the this first condition holds, no? Then the first condition holds. Second, we need to show that the sum of these values is equal to 1. No? So condition 2, we want to show that the sum of these must be equal to 1. So f of x1 plus 2 plus up until fx of 5. So if we're gonna add this is equal to 5. Thus, the second condition holds. Therefore, the given function can serve as PMF of the random variable having range 1, 2, 3, 4, and 5. Okay, so we have shown that this function where x ranges from 1 to 5 can serve as a PMF of a discrete random variable, since condition 1 and 2 holds, no? So we have shown that this one are all non-negative, which is this. And then the second one, we want to show that the summation must be equal to 1. So if we're gonna add this will equal to 1. Okay. So we have remarks on the discrete random variables. We have, I think, 5. Okay. So the values in the range of x are called the mass points. Discrete density function, discrete frequency function, and probability function are other terms used in place of PMS. So don't be confused. Kani sila. Kani nga mga terminologies. So discrete density function, discrete frequency function, and probability function. So are other terms used in place of PMF. Also, the notation, muna akong giingon, no? So the notation p of x is sometimes used instead of this function. So some books will use this notation, some books will also use this definition. So basahan po ninyo ang ilahang sa books. Basahan ninyo kung unsa ang ilahang pag-unsa nila pag-define ang discrete random variable. Next, the PMF can be written down using the indicator function as follow. So we can write our PMF as the indicator function. So sometimes sa books naka-indicator function sila kana. So PX, this is a piecewise, no? So na siya. So try to write this in piecewise or in this indicator function form. Okay, kani. Try nyo. Try to write this in indicator function form. And if the range of x is finite, then the PMF can be represented in a tabular form as follows. So aside from indicator function, you can also write this one as a tabular form as this. Okay. Third one is the discrete CDF has steps at mass points. That is, at the mass point xj, the CDF has a step size of p of xj, and the CDF is flat between mass points. So later, I'm gonna show you, no? So, ano siya nga na step function. This is a step function. Steps. So you have steps. So later, I'm gonna show you ako example, no? Ato po i-plot siya. And the PMF of the discrete random variable x, discrete random x can be used to determine the probability of any event expressed in terms of x. That is, we can solve this one, probability of this. And just like the CDF, the PMF of a discrete random variable is uniquely defined. We also have here another definition of CDF of the discrete random variable. So if x is a discrete random variable, the function is given by the PDF, or the CDF is given by this, which is, I think na kuan na ko siya, naingon na ko siya ganina, no? Muna siya. Asan to? Here, I think, yeah. And this. So it's just the sum of the CDF is just the sum of this PMFs. So it is called this distribution function or the cumulative distribution function of x. So we have two theorems here. So we'll have example of each theorem. Okay, so for the discrete random variable, we have theorem here. So the values f of x of the CDF of a discrete random variable x satisfies the following condition. So you have 2, and if a less than b, then the CDF of a is less than or equal to CDF of b for any real numbers a and b. Okay. So example of this. example. So example. So find the distribution function. Distribution function of the total number of heads obtained in 4 tosses of a balanced coin. So you have 4 coins, no? So four tosses, not 4 coins, 4 tosses of a balanced coin. So only one coin, and then you toss it 4 times. And then count the number of heads. So we want to find the distribution function of that total number of heads obtained in 4 tosses of a balanced coin. So the possible outcomes, no, we have all heads, natay head isa, and then padung siya sa nakay tail head po. Ngayon napod kay puro tails, no? So actually this is all for 16 na siya kabuok. And so note that so if we have 0, isa lang, no? If we have 0 or no heads at all, we have 1/16, which is this one. Gani lang. If say naatay f of say isa, so naa kay kani, and napa na siya sa tunga, so daghan na sila. We have 4 out of 16. If say f of we have 2, we have 6/16. If we have 3, 4 out of 16. And if say full, no, so we have 1/16, which is this. So it follows, so from our it follows that our f of 0 is just the sum, or this, or 1/16. Our f1 is fx0 plus fx1. This is 5 out of 16. So this fx2, f0 plus fx1 plus fx2, we have this is 11/16. So if x is 3, we have x0, 1, 2 plus 3. So we have 15/16, and say fx4, this is x0 plus 1, 2, 3, and 4. Oops, wrong. This is x4. This is equal to 1. So from here, we can write our CDF. The CDF is given by So f of x, this is a piecewise function. So you have 0, 1 over 16. This is 5 over 16, 11 out of 16, 15, 16, and then 1. X, the value 0 if x is less than 0, no, and then 1 over 16 if x is less than or equal to x, if x is greater than or equal to 0 but less than 1, then 5 over 16 if, say, x is less than or equal to 1 but less than 2, x 11 over 16 if, say, x is less than greater than or equal to 2 but less than 3, 15 out of 6, 15 over 16 if, say, x is greater than or equal to 3 but less than 4, and 1 if greater than or equal to 4. So this is our CDF. Okay. So next theorem, if the range of a random variable x consists of the values this, then our PDF or PMF is equal to the this one, our first value, no? And then x sub I is, we can look for our PMF from our CDF function here. So example, example, imagine a discrete RVX, a discrete random variable x representing the number of heads, the number of heads in two coin tosses. And the following is the CDF. So you have the CDF function now. So this is the CDF given. So 0 if x is less than 0, 1/4 if, say, x is greater than or equal to 0 but less than 1, 3/4 if x is greater than or equal to 1 but less than 2, and then 1 if, say, x is greater than or equal to 2. So we have this CDF. So if ito na siyang i-plot, oh, kiwi, sige. If mo na itong plot, no, CDF, ito na i-plot na CDF. So the values x kay 1 or 2 lang, 0, 1, 2. So this is 0, this is 1, this is 2. And then say mo na siya ang 1/4. This is 1/2. So this is 3/4. So this is what? So, ingon siya diri kung 0 is 0, no? If x is 0, paingon siya diri. Siya muna siya. Ana sila. And then, if x equals 0 but less than 1, so naa siya diri, 1/4 yung value. So, this is included, and then this is not. Because of this. Kani, oh. Muna siyang, na siya 0, ay, na siya open. And then 3/4 if x equals 1, so a 1 is included, then 2 is not. And then 1 naman if x equals 2. And paingon siya dito na. So, muna siya ang ato ang itsura, ato i-plot, no, si CDF. So, na siya step, or siya steps. Alright. Okay, so balik sa example na to, we want to calculate the PMF using the CDF given given the video, given the CDF. So, atong gamiton kani na theorem, this one. So, i-minus lang nato iyang previous na value ng CDF. For example here, to solve for PMF, so we have gamit atong kanino minus fxi minus fxi minus 1. So our f of 0, this is f0 minus the before 0, which is this is given by here. So 0 ang before 0, and then if 0 siya, 1/4. So this is 1/4 minus 0, which is 1/4. Okay. Next, ang f1, this is fx0, 1. This is 1 minus fx0. This is equal to 3/4 minus 1/4, which is equal to 1/2. And then f of x2, this is f2 minus fx1. This is 1 minus 3/4. This is just 1/4. So here's our PMF. So if we check, our property, or a double check that if this is PMF or not, you just want to check that if these are non-negative, check dito, no, ato ang kani conditions, it must be non-negative and the sum must be equal to 1. So non-negative here, 1/4, 1/2, 1/4. And if we add this, so 1/4 plus 1/4, this is 1/2. 1/2 plus 1/2 equals 1/2. So thus, this is a valid PMF. Okay. So next week, we're gonna discuss about the continuous random variables. So if you have any questions or clarifications, ah, message mo sa space or before ta mag-start sa tong class next week. Okay? And see you